Welcome back to my YouTube channel Sriram Devarajan. Today I am going to discuss another set of problem from KSET from the year 2024 Mathematical Science question paper. Today I am going to discuss 10 problems from KSET 2024 starting from the problem 1. Limit n tends to infinity 1 by n square plus 2 by n square plus 3 by n square plus plus n by n square. Is first option 1 by 2, second option 0, third option 1, fourth option infinity. We have to find the limit value for this 1 by n square plus 2 by n square plus 3 by n square, at last n by n square. Whether the first option 1 by 2, second one 0, third one 1, fourth one infinity. Solution. What is given? Limit n tends to infinity 1 by n square plus 2 by n square plus 3 by n square plus n by n square. We can write this one as limit n tends to infinity 1 plus 2 plus 3 plus plus n by n square. See, in the numerator it is in the form of 1 plus 2 plus 3 up to n, sum of first n natural number. We know very well sum of first n natural number is n into n plus 1 by 2 divided by n square. This is nothing but limit n tends to infinity n into n plus 1 by 2n square, which is equivalent to limit n tends to infinity n square plus n by 2n square, which is equivalent to limit n tends to infinity n square by 2n square plus n by 2n square, which is equivalent to limit n tends to infinity 1 by 2 plus 1 by 2n. This time the answer is 0 if n approaches towards infinity after applying the limits. Answer is 1 by 2 plus 0. Answer is 1 by 2. For this problem, option 1 is the correct one. Now I am going for the second problem. Which of the following matrix? Which of the following matrix is positive definite? First option 1 2 3 4, second option 1 minus 2 5, Third option 1 minus 2 minus 2 5. Fourth one 1 0 0 minus 4. Solution. Option 1, I am going to check whether this matrix is positive definite. What is option 1? 1 2 3 4. This is 2 cross 2. A1, which is 1 greater than 0. A2, full 2 cross 2 matrix. 1 2 3 4. Find the determinant. Determinant 1 2 3 4, which is equivalent to 4 minus 6, which is minus 2. One of the values positive, another value is negative, that is less than 0. Option 1 is not positive definite. Both the value must be greater than 0, A1 and A2. Now I am going to check option 2. Option 2, what is given? 1 minus 2 minus 2 5. Find A1, 1 positive. Find A2 with the determinant 1 minus 2 minus 2 5. 5 minus 5. Second option minus 5. Minus 5 minus 4, which is minus 9, less than 0. Option 2 not positive definite. Option 3 1 minus 2 2 5. Here A1 is 1 greater than 0. What is A2? Determinant 1 minus 2 2 5, which is equivalent to 5 plus 4, which is 9 greater than 0. Both A1 and A2 greater than 0. A1 means I am taking 1 cross 1. A2 means I am taking 2 cross 2. Full matrix. The answer for A1 positive, A2 positive. Option 3 positive definite. For this problem, third one is correct one. Third problem. If A equal to 3 minus 2 4 minus 2 satisfy the matrix equation A square minus Ka plus 2i, which is equivalent to 0, then what is the value of k? First option 0, second option 1, third option 2, fourth option 3. Solution. Given matrix A, which is 2 cross 2, satisfy the matrix equation A square minus Ka plus 2i. Then we have to find the value for k. First option 0, second option 1, third option 2, fourth option 3. What is A? Matrix 3 minus 2, 4 minus 2. First of all, find the characteristic equation. The characteristic equation is lambda square sum of the diagonal into lambda plus determinant 3 minus 2, 4 minus 2, which is equal to 0. This is lambda square minus lambda plus minus 6 plus 8, which is equal to 0. Lambda square minus lambda plus 2, which is equal to 0. We know very well every square matrix satisfies its own characteristic equation by Cayley-Hamilton theorem. This equation now becomes a square minus a plus 2y, which is equal to 0. Equation 1. Compare 1 with a square minus ka plus 2y equal to 0. If we compare, k is nothing but 1. For this problem, option 2 is the correct one. Now I am going to discuss the fourth problem. If A is 2 cross 2 matrix over R with determinant A plus I, which is equal to 1 plus determinant A. First option, trace of A is 0. Second option, determinant A equal to 0. Third option, A equal to 0. Fourth option, determinant A not equal to 0. What is given? A is 2 cross 2 matrix with determinant of A plus I equal to 1 plus determinant A. We have to check which option is the correct option for this problem. Solution. Since A 2 cross 2 matrix, therefore lambda 1 lambda 2 be the eigenvalue. We know very well lambda 1 plus lambda 2, which is equivalent to trace lambda 1 into lambda 2, that is nothing but product of eigenvalue, which is equivalent to determinant A. If lambda 1 and lambda 2 be the eigenvalues of A, lambda 1 plus 1 lambda 2 plus 1 be the eigenvalue of A plus I. Lambda 1 plus 1 into lambda 2 plus 1, which is equivalent to product of eigenvalue. This is nothing but determinant of A plus I. Since in the problem itself it is given determinant of A plus I equal to 1 plus det A. Determinant of A plus I is nothing but product of eigenvalue lambda 1 plus 1 lambda 2 plus 1 1 plus determinant of A, product of eigenvalue for the matrix A. Simplify lambda 1 into lambda 2 lambda 2 lambda 1 plus 1. I am multiplying lambda 1 plus 1 into lambda 2 plus 1, 1 plus lambda 1 lambda 2. These two will get cancelled, 1 will get cancelled, lambda 1 plus lambda 2 which is equivalent to 0. This is nothing but trace of A which is equivalent to 0. For this problem, first option is the correct one. Now problem number 5. The row space of a 20 into 20 cross 40 matrix A as dimension 14, what is the dimension of the space of AX equivalent to 0. First option 26, second one 14, third one 34, fourth one 6. See, row space for the matrix 20 cross 4 with the order of the matrix A 20 cross 40, the row space has dimension 14. We have to find the dimension of the space AX equal to 0. First option 26, second one 14, third one 34, fourth one 6. Solution. What is given? Row space. Row space is nothing but rank. Rank is given as 14. We have to find dimension of space of AX equal to 0. This is nothing but nullity. We know by rank nullity theorem, rank of A plus nullity of A dimension here dimension is 40 because M cross N, here N is 40. Rank of A is 14, nullity of A we have to find. Nullity of A 40 minus 14, 26. For this problem, first option is the correct one. Now the problem number 6. Consider the sequence un 1 plus minus 1 power n 1 by n power n. Then limit n tends to infinity supreme of un which is equal to limit n tends to infinity, infimum of un is 1. Second one, limit n tends to infinity, supremum of un which is equal to limit n tends to infinity, infimum of un which is equal to 1 by e. Third one, limit n tends to infinity, supremum of un which is equal to limit n tends to infinity which is equal to e. Fourth one, limit n tends to infinity, supremum of un is e, limit n tends to infinity, infimum of un is 1 by e. Here the sequence is given 1 plus minus 1 power n, 1 by n power n. We have to find out supremum of un and infimum of un. Whether both are equal, the value is 1. Second option, both are equal, the value is 1 by e. Third one, both are equal, the value is e. For the fourth one, supremum is e, infimum is 1 by e. Solution, what is given? un 1 plus minus 1 into 1 by n power n. We can write it as 1 minus 1 by n power n if n is odd. For n odd, this value becomes minus 1 by n. If n is even, it becomes plus 1 by n power n if n is even. Now I am going to apply limit n tends to infinity un, limit n tends to infinity 1 minus 1 by n power n 1 plus 1 by n power n. Here if n is odd, here if n is even. Limit n tends to infinity 1 minus 1 by n power n is, value is e power minus 1 1 by e. Limit n tends to infinity 1 plus 1 by n power n which is equivalent to e. Therefore, supremum is e, infimum is 1 by e, because value for e is 2.713. For this problem, fourth one is the correct one. Supremum of un is e, limit supremum un is e, limit infimum un is 1 by e. Now I am going to discuss problem number 7. Which of the following statement is true. First one, the set of all rational number is uncountable. The complete metric space without isolated point is uncountable. If A and B are countable, then the Cartesian product A cross B is uncountable. Set of all irrational number is countable. Solution. For the seventh problem, we have to check whether which one of the statement is true among the four. See, the first statement, a set of all rational number is uncountable. We know very well, set of all rational number is countable. This is false statement. See, in the fourth option, set of all irrational number is countable. We know very well, set of all irrational number is uncountable. This one, false statement. See the third one, if A and B are countable, then the Cartesian product A cross B is uncountable. Well-known result, if A and B are countable, then the Cartesian product A cross B is also countable. Third one is false statement. True statement is second one. Here for this seventh sum, option 2 is true statement. Now, eighth problem. The radius of convergence of the power series summation n equal to 1 to infinity 1 plus 2 by n square power n square z power n is first option E, second one 1 by E square, third one 1 by E, fourth one 1. We have to find radius of convergence for the power series, whether option 1 E correct one or 1 by E square, second one correct one, third one 1 by E, last option is 1. If you compare power series an z power n, here what is an? 1 plus 2 by n square power n square. For finding radius of convergence, we have one formula: limit n tends to infinity, supremum modulus of an power 1 by n. Now find an power 1 by n. 1 plus 2 by n square power n square into 1 by n, which is nothing but 1 plus 2 by n square power n. Now find limit n tends to infinity an power 1 by n, limit n tends to infinity 1 plus 2 by n square power n. This part becomes 0 if you substitute limit for n, which is tends to infinity. This part becomes infinity, this part 0. It is of the form 1 power infinity. If it is of the form 1 power infinity, we may write like this: e power limit n tends to infinity 2 by n square into n, which is equivalent to e power limit n tends to infinity 2 by n, which is equivalent to e power 2 by infinity. Anything 2 by infinity means e power 0. Answer is 1. Therefore, R, which is equivalent to 1. For this problem, fourth one is the correct one. Now, problem number 9. The number of surjective maps from a set of five elements to a set of 3 elements is option A 150, option B 243, option C 125, option D 124. For this problem, we have to find a number of surjective maps. Surjective means onto map from a set of 5 element to a set of 3 element. Surjective means onto. Injective means 1 1. Bijective means 1 1 onto. Whether the first option 150, second one 243, third one 125, option D 124. Which among the 4 is the correct one for this problem number 9? Solution. I am going to use this result for solving this problem. Result is the number of elements in set A is m, and number of elements set B is n, then number of surjective maps from A to B is 0 if m less than n, summation r equal to 1 to n, r equal to 1 to m minus 1 power n minus r ncr r power m greater than or equal to n. Here number of elements in A is m, which is equivalent to 5. Number of element B, which is equivalent to 3. Clearly 5 greater than 3. Use this one, that is summation r equal to 1 to m minus 1 power n minus r ncr r power m. Therefore number of surjective maps from A to B is summation r equal to problem number 9 given as number of surjective, that is onto map from a set of 5 element to a set of 3 element. Check the option whether first option 150, second one 243, third one 125, fourth one 124. I am going to use the result. If the number of element in set A is m, number of element in set B is n, then number of surjective, that is onto map from A to B is, if m less than n, answer is 0. If m greater than n or equal to n, summation r equal to 1 to n minus 1 power n minus r ncr power r power m. Here n of A, which is m, that is 5, n of B, which is n, that is 3. Clearly 5 greater than 3. Use the result summation r equal to 1 to 3 minus 1 power n minus r ncr r power n minus 1 power 3 minus 1 3c1 1 power 5 plus minus 1 power 3 minus 2 3c2 2 power 5 minus 1 power 3 minus 3 3c3 3 power 5. Simplifying, minus 1 power 3 minus 1, that is minus 1 square, plus 1 3c1 3 by 1 1 power 5 1 minus 1 power 3 minus 2 minus 1 power 1 3c2 means 3 into 2 by 1 into 2 2 power 5 32. Last one minus 1 power 3 minus 3 minus 1 power 0 1 3c3 again 1 3 power 5 243 This is first term 3, second term simplification after getting the answer minus 96, last term 243. 243 plus 3, 246 minus 96, 150. For this problem number 9, option 1 is the correct option. The last problem, 10th one, for a real symmetric matrix A and B, which of the following is true? Whether first option AB equal to BA, second one AB is symmetric, third one AB equal to BA, all eigenvalues of AB are real, fourth one AB is invertible if either A is invertible or B is invertible. I am using result for this problem real symmetric matrix. The result is first one, if A and B are symmetric, then AB is symmetric if and only if AB equal to BA. Second result, all the eigenvalues of real symmetric matrix are real. See, in the first option only AB equal to BA. It is possible if AB is symmetric matrix. Option 1 false statement. See, second one AB is symmetric matrix. Again it is possible AB equal to BA. Again false statement. First one, second one false. Option 3 AB equal to BA, then all eigenvalues of AB are real. It is true because AB equal to BA, from the first result AB is symmetric. Once AB is symmetric, eigenvalues of AB are real from the second result. From the second result, the matrix eigenvalues of real symmetric matrix are real. Therefore, AB is BA means AB equal to BA means AB is symmetric. Once AB is symmetric, eigenvalues of AB is real from the second result. Now I am going to show the fourth one is a false statement by taking counter example. Take A 2 cross 2 1 1 1 1, B identity matrix 1 0 0 1. Find determinant A. For this one 0. Determinant B, answer is 1. Since determinant A is 0, A is not invertible, but determinant B is 1, B is invertible. Find the product AB. A, B is I, A into I is A, AB equal to A, but determinant of A which is equivalent to 0, it is not invertible. AB is invertible, is not possible because AB is equivalent to 0, not invertible. Therefore, for this 10th problem, only the third option is the correct one. All eigenvalues of AB are real if AB equal to BA. This is part 1 of my KSET 2024 Mathematical Science question paper. I will upload more problems from KSET 2024. I already uploaded KSET 2013. Part 1 is available in my playlist. Totally 5 parts are available in my playlist. You go to my YouTube channel, check the playlist. You may watch all the videos of part 1, part 2, part 3, part 4 and part 5. This is part 1 of KSET 2024. Subscribe my channel, share my channel to your friend and like my channel. Thank you.